Hello everyone, welcome to our daily physics problem, day 11. So today we are going to look at the hardest problem ever solved. A wooden block that can rotate around the horizontal axis at the lower end on a vertical wall. At the beginning, the angle between the board and the wall is 15 degrees. Put a cylindrical stick with radius of r. In the angle, add a force F to the outside of the board to keep it balanced. Then draw a vertical straight upward arrow at the center of the surface of the stick, a cross section. It is known that the static friction factor between the stick and the wall is μ1, and the static friction between the stick and the board is μ2, is 1 over square root of 3. With a slowly gradual decrease of F, the angle slowly opens and the stick falls. Ask what will be the direction of the arrow points when the angle is 60 degrees. So here I wanted to pause the video, try to solve it on your own. After you tried, come back to the video and I will show you how I did it. Oh, so welcome back guys. So in this problem, when we want to know the total angle it rotate, the arrow rotate in this process, we need to know which direction it's rotating. And the direction is based on the friction of the stick it feels. So let's draw all the forces here. Try to balance the force. First we have a gravitational force, 2 normal force, 2 friction force, and an F, additional F, that make it balanced. So based on the reference frame of our stick, we can lay out our system equation of the balancing force and torque. So first in the horizontal direction, we have N1 plus F2 times, because this angle is theta, times sine of theta is equal to N2 times, we know this angle is theta, this is 90 minus theta, so it will be N2 times sine of theta. Oh no, not sine of theta, it's cosine of theta. Sine of 90 minus theta, which is cosine theta. In the vertical direction, we have F1 plus F2 times cosine of theta plus N2 times sine of theta is equal to mg. Then for the torque, we'll balance as the 2 friction times the radius of the circle. So now we need to think which direction is going. So we need to find whether the left torque is bigger or the right torque is bigger. Let's find the limiting case, which just separate the two different directions of sliding. And then let's see whether a little bit bigger or a little bit smaller, which way the stick will slide. So from the torque equation, we can derive out that N1 times μ1 is equal to N2 times μ2. Then we just need to solve neither of N1 or N2. First at the first horizontal equation, we can simplify as N1 plus N2 times μ2 times sine of theta is equal to M2 times cosine theta. Then we can solve for N1. We can express as N2 times some cosine and sine. Then we plug it back into our torque equation. We got cosine of theta minus μ2 times sine of theta times μ1 is equal to μ2. Then we know μ1 is equal to 1. μ2 is equal to 1 over square root 3. So we have cosine theta minus sine theta divided by square root of 3 equal to 1 over square root of 3. We multiply both sides by square root of 3 and then do some move the sign to the right. Then we square both sides. We plus both sides by 3 sine square, so that we can get rid of the cosine. And then we factor, do a little bit simplification, our standard form. We can solve for sine theta. Let's first do some factoring. We can see 2 sine theta plus 2 times 2 sine theta minus 1 will be equal to 0. So we know sine of theta 1, the first solution equal to negative 1. That doesn't make any sense because we can't get the angle that far. So second will be got the theta 2 will be equal to 30 degrees because sine of theta 2 equal to 1/2. So within 15 degree to 60 degrees, which is acceptable solution. So now we know the limiting case of the turning point of the sliding. So we know now if angle theta is smaller than 30 degrees, it slide to the right. If the theta is bigger than 30 degrees, the stick will slide to the left because the right torque is bigger. Then we can draw another diagram to help us think in the simplified problem we just did. First, we have our little ball, the little stick, stuck on 15-degree angle. After a while, it dropped to our 30-degree angle, and then last it dropped to our 60-degree angle. Okay, so let's define the distance they traveled the first time is h1, second time is h2. Then this angle is 15, this angle is 30, and this angle is 60 degree. And all the radius are r. And let's do a little bit line here to help us do some geometry later. Then we know if we think about how many angle it traveled from 15 degree to 30 degree, we can know first calculate h1. h1 will equal to r divided by tangent 15 degree minus r divided by tangent 15 degree. Oh no, the first one is 7.5. So the second one will be h2 will be from 30 degree to 60 degree. We have r divided by tangent 15 minus r divided by tangent 30. Then let's solve for the first angle. How many angle it rotate to the right. We have phi 1 is equal to h1 divided by r. And trust me, I did some calculator work. The answer we got, finally we transform into degree, got 221. And for phi 2, we have h2 divided by r, which is equal to 114 degree. Then if you define the right rotation of the positive, left rotation as negative, we are 221 minus 114 plus a 30 degree, because we also need to calculate the angle the plane traveled in the second rotation, because the block is going on the right side. So when the plane is rotating, the block is rotating with it. Not the first half, but the second half. So that's we got our final answer here, 137.